Hi everyone, greetings from Stella Maris College. I am Dr. Chinthamani, Assistant Professor from Department of Mathematics. I welcome you all to the introductory video for the course Complex Analysis, a Geometric Approach. Complex analysis is one of the fascinating subjects. When you hear the word complex numbers, the questions like, will they exist? If yes, where do they exist and why we need it? You will get answers for all such questions if you undergo this course. This course provides an introduction to complex analysis. It consists of 8 modules for 8 weeks. The modules 1 to 3 are devoted to genesis of complex numbers and algebra of complex numbers and its sets. The modules 4 to 6 are dealing with complex functions and conformal mappings. Module 7 is devoted to applications of complex functions and applications of conformal mappings. Module 8 is specially designed with the geometric function theory, which speaks more on geometric aspects. A pair of modules contain a homework assignment that will require time to think through and practice the concepts discussed in the lectures. Any student from other majors and engineering stream also will get benefit out of it, as complex numbers has enormous applications. The following are the course objectives: to enable the learner to know the genesis and need of complex numbers, to introduce the complex numbers through geometrical aspects, to identify analytic functions and to know its importance, to expose a fertile area of complex variables such as transformations and conformal mappings as a source of powerful technique that are widely applied in sciences and advanced engineering mathematics, to introduce geometric function theory, which lays foundation for research in complex analysis. The week 1 contains the module which is talking about geometry of complex numbers. Out of this module, you will be able to understand the origin and development of complex numbers, locate the complex numbers in complex plane, and knowing spherical projections. By week 2, the module 2 is on algebra of complex numbers, and on successful completion of this module 2, you will be able to perform the basic operations on complex numbers by using Cartesian coordinates and polar coordinate system. Module 3, which is during the week 3, is about sets of complex points, which is completely talking about the various types of sets, and out of this you will be able to understand the sets and sketching the sets of complex points. Week 4 is on analytic functions, and this analytic functions module contains complex functions, limit differentiability of a complex function, CR equations in Cartesian and polar coordinates, and various properties of analytic functions you are going to study. On successful completion of this module, you will be able to check analyticity of complex functions, which has greater importance in engineering sciences. And module 5 speaks about elementary functions. This is actually on geometry of complex functions as mappings from Z plane to the W plane, and the various elementary functions like exponential functions, trigonometric functions, and hyperbolic functions you are going to see in this. And the course learning outcomes of this module 5 is to analyze elementary transformations based on exponential and trigonometric functions. And through this week 6, you're going to see the module 6, which is completely on elementary transformations and conformal mappings, which is talking about linear, bilinear transformations, isogonal, conformal mappings, and critical points. So out of this module, you'll be able to perform the mappings of complex functions and finding the images under transformations. And module 7 is completely about applications of complex functions and applications of conformal mappings. And from this, you'll be able to know what are all the filters available in signal processing, and you will be coming to know about the image processing, where you can apply the complex numbers and understand the wide applications of all other complex variables in engineering and science domains. And module 8 is completely devoted to geometric function theory, as I said, and it is talking about univalent function, unit disk, normalization, subordination, star-like domain, convex domain, which has the greater geometrical aspects of complex function theory. So each module consists of 2 to 3 video lectures with embedded problem sets. Modules 2, 4, 6 and 8 contain assignments on previous model topics. Through this, a significant amount of your learning will happen while completing the homework assignments. These assignments are not meant to be completed quickly. Rather, you will need paper and pen with you to work through the questions. At the end of each module, I have given course learning outcomes that as we discussed early, so it will be done through grading assignments. The course is designed not only for mathematics students, it is also applicable students from other streams and engineering sciences. For this reason, it is typically taught without a strong emphasis on proofs. Students planning to do undergraduate research may also find this course in complex analysis as a useful stepping stone to do projects in complex dynamics, differential geometry, or analytic number theory. At one end of the spectrum, the subject provides a powerful set of tools that are dealing with the linear transformations, bilinear transformations, conformal mapping, which are having a lot of applications. While at the other end, it is a deep and unifying subject that has a strong, pure mathematics feel. Studying maths can be done by doing maths. So, though the name is complex analysis, it is not complex to learn. Happy learning and thank you.